panel. The next panel is very exciting. It's focusing on industrial IoT, so it's a good segue, focusing on industrial IoT, but looking at the convergence of 5G, edge compute, and AI. And so I'll hand off to Prit Banerjee. He's a CTO at ANSYS. I've known Prit for a long, long time, remarkable career. Just read his bio. I'm not going to be, so that's a quick, brief introduction. But Prit, thanks a lot. Thanks for participating and leading this session.
Thank you very much, Sujit. Can you hear me?
Yes, we can hear
Yes, perfect. And thank you for inviting me and the panelists to this session on the convergence of 5G, edge compute, and AI/ML. And my good friend Amitabh, I have known him for many, many years. He gave a fantastic keynote, sort of positioning the topic. And our panelists today will expand on what Amitabh just shared with all of us. So this particular topic that is a discussion of a panel. So let me sort of introduce myself. I am CTO at ANSYS. Previously, I used to be CTO at ABB and Schneider Electric. And in those worlds, I mean, ABB, Schneider Electric, they're sort of making power and automation equipment on, say, factory floors. And as CTO, I was responsible for helping them build their IoT platforms, the Ability platform at ABB, the EcoStruxure platform at Schneider Electric. And the reason they're interested is, well, they have all these different assets. It could be ABB's transformers or robots or whatever, right? And you put them on a factory floor. And in the past, as Abhidava mentioned, all these devices are connected through wired networks. But the future is all wireless, right? And so, but in a wired network, you can have very high bandwidth. Really, you can guarantee the latency and so on. In a wireless, you don't. And so now all these companies are looking at the future of manufacturing and sort of smart manufacturing enabled by 5G. And we are sort of looking at the future of 5G in 6G and so on. So what has happened is there is a role for faster connections, right? It's about dense connectivity and so on. So in these future application areas of Industry 4.0 in manufacturing, you absolutely need connectivity. But in addition to connectivity, you need compute, right? In the past, you had all the compute happening on the servers, but now increasingly compute is moving to the edges, right? So you have an asset like a transformer or whatever, right? You want to do some computing at the edge itself before you ship off larger computes to the cloud. And then what is happening is, as Amitabh mentioned, you have this increasingly AI/ML that is coming around and impacting all our lives. So when I was at ABB and Schneider, we were talking about, well, okay, let's do some AI/ML to do much more better predictive analytics. Here is a manufacturing thing that is about to fail. Can we better predict it's about to fail or not? You can do it through collecting lots and lots of data. You do it through AI/ML. But AI/ML, as everybody knows, is based on lots of training data. So now you do all the data training on the cloud. Once you have the trained model, you push that trained model to the edge. And at the edge is where you are actually collecting signals, right? And then you use that trained AI model at the edge on your edge device to do smart analytics. So Amitabh mentioned this whole concept of digital twins. Everybody, the entire industry, all the automation companies, it's ABB, Schneider, Rockwell, Honeywell, everybody is talking about digital twins. And we at ANSYS are today working on digital twins, which is sort of physics-based digital twins, right, to complement the data-based digital twins in this future industry. So I couldn't be more excited to talk about this panel. And the convergence of three areas that we're going to talk about. We have got on the panel panelists from Ericsson, right? So Malik Tatimpola, who's the CTO at Ericsson, he's going to bring in the 5G expertise. We have Vish Nandalal from Dell. He has got tremendous experience in the past in networking in companies that he will talk about, right? But today he's going to represent sort of the edge in his representing sort of Dell. And then we have on the panel Anima Anandkumar, who is just an amazing leader. She's a professor at Caltech as well as a part-time 50% employee at NVIDIA. As many of you know, NVIDIA has been absolutely blazing the trail in terms of AI ML being enabled by GPUs and so on. And then we have Dinesh Kumar from IBM, works at IBM Research, bringing tremendous sort of ideas as to how all of these things will come together. So with that, I want to introduce the panelists and to each of them to talk briefly about their background and their companies. So I'm going to start with you, Vish. Talk about yourself, your background, and your company, please. Vish.
Thanks, Preet. My name is Vish Nandlal. I'm the Vice President of Technology Strategy and Ecosystems at Dell Technologies. I'm focused on a lot of what our emerging product portfolio is going to look like, including Edge, 5G, AI. So I think I get the trifecta here with all the topics that we're going to be discussing. But my journey while it's here currently, I've previously been within the service provider space. I was CTO of a service provider in Australia, and prior to that was CTO North America at Ericsson, and the Nortel CTO for wireless back in the days when North America still had a network equipment provider.
Thank you, Vish. Malik, why don't you introduce yourself?
Good morning. Thanks, Pete. Hello, everyone. My name is Malik Tadikamla. I'm a CTO of Ericsson Silicon Valley. So my focus areas are essentially how these technologies are coming together to create the next generation systems. So how 5G, SDN, NFV, compute, AI, machine learning, and security, how all these technologies are coming together to realize the systems. So prior to Ericsson, I've been in the telecom industry for about 30 years, worked at Nortel, Motorola, Cisco, Juniper, F5, and Ericsson. So I've seen the journey of how networks evolved from 2G to until now 5G and beyond. Thanks, Pete.
Thank you very much, Malik. Anima, why don't you introduce yourself?
Hi, I'm Anima Anand Kumar. I'm a professor at Caltech as well as director of AI research at NVIDIA. And through these roles, I'm attempting to bridge the gaps between industry and academia. So I work on a range of AI algorithms with focus on looking at reinforcement learning, meta learning, tensor methods, how to exploit the higher dimensionality in data, unsupervised learning. And in fact, my first project back in my PhD was on wireless sensor networks, how to collect data while minimizing transmission costs, how to exploit the correlations in data. That's what got me into machine learning through a more non-traditional route. So it's great to see convergence of all these areas coming together.
Fantastic. Thank you, Anima. Dinesh,
Hi.
your background, please.
Okay, thank you. I'm Dinesh Verma. I have a very simple background. After my PhD, I've been working at IBM for close to 30 years, at IBM Research specifically. My background is I did my PhD in computer communication networks. And then at IBM, I have been working on different applications of that as IBM has shifted from being a network equipment provider, which it was in the early 90s, to basically being just a provider of servers and software that work in a distributed environment. My current role is that I am the worldwide strategist for IBM research in the area of 5G and Edge. And before that, I was the leader of the work in IoT/Edge. So essentially, this panel is very interesting to me because of the fact that 5G, Edge, and building IoT applications and other enterprise applications that leverage that is basically the focus of my research and the business impact that I strive to bring to my company.
Thank you so much, Dinesh. And as you can see, look at the background of the panelists. We couldn't have picked more expert panelists for the topic on the convergence of 5G, edge, compute, and AI. So let's start with the first of these topics, the topic of opportunity of 5G in the industrial IoT applications. I'm going to start with Malik. What do you see are the opportunities of 5G in IoT applications in the industrial world?
I think when you compare 5G versus 4G, 5G brings the three major attributes, right? First one is the throughput. The second one is latency and delay. The third one is a connection density. So these are the three parameters that are really helping push the connectivity beyond mobile broadband into industrial IoT. So again, there are two types of industrial IoT segments, right? One is the massive connectivity where latency is not really the problem. The second type of connectivity is where the latency becomes critical in terms of mission critical nature. And in the process, what we are realizing, when I talk to my sales folks, we are learning that there are so many places connectivity is not there yet. We are working with one of the mining company in Canada where one has to go 3 kilometers below the ground to the mining facilities. So where they have to put, they cannot have fiber because of the blasts taking place every now and then. So we are looking at such kind of use cases where the connectivity makes a difference for any type of remote operations and maintenance purposes. So it's amazing for me, at least as a learning, to see how much of the world is still not connected and how 5G can help.
Fantastic. Thank you. So I'm going to ask Vish to add his thoughts. I mean, because of his tremendous background in companies where he worked at Nortel and Telstra and others. Can you share your perspective, Vish, on sort of the opportunity of 5G? I will talk about edge compute later, but your earlier roles, what do you see your opportunity of 5G?
Absolutely. Well, we are moving towards a software-defined industrial pyramid, if you will. When I think of how these control systems have emerged in the past, they tended to align themselves against a different evolution timescale than how the internet did. You still got these weird field buses that exist within industrial control systems that are used to, really try to, lower the cost of what the physical install plant looks like. And they've got some very precious capabilities that are designed. If you go up the pyramid from IO, you've got these programmable logical controllers that were defined back in the 60s. You've got supervisor control and data systems. And then, above that, you've got MES systems. And finally, you get all of your applications and businesses processes talking through ERP. The question is, how do I take that pyramid and then leverage some of these more modern technologies? And there's going to be, an issue that is at the heart of this, which is a transformation process. So certainly, when I look at 5G in the context of the SCADA system, there's an opportunity to leverage the time-sensitive networking capabilities, ultra-reliable, low-latency links to support that infrastructure. If I go kind of further up the stack and I look at the management or manufacturing execution systems, that's where services like network slicing can come into play. You coordinate that with some of the telco cloud-based capabilities being driven by this new 5G RAN architecture, and suddenly you've got a system that can optimize for where do I want to place functions such that they can optimize flexible production and low cost. So we're really creating a set of new assets that can be integrated into the automation pyramid of a particular industry, and I think that's going to be a journey that's going to require probably a previously kind of unheralded partnership between the industrial players and the wireless players, and I still have yet to see that really connect as profoundly as it needs to.
Thank you, Vish. So I'm going to keep you on the first sort of following up your discussions, but this topic is going to be what do you see as the opportunity of edge compute, right? So we're going to move from 5G to edge compute, and now in your role at Dell, right? What do you see the opportunity for edge compute in industrial IoT? I'm going to start with you, Vish, and then move on to some of the other panelists.
Yeah, certainly. If I do the easy mapping between industrial control systems and edge, clearly I can put a virtual PLC. I can start blurring that line between your legacy system and enable a capability to actually do the swing over of a legacy system to the new system. But I think, if we're really going to express the potential of edge computing, we're going to need to go beyond that. There's opportunities to start to, apply AI in the edge to really, coordinate some of these autonomous systems that are, pairing together to make optimal decisions. And by deploying AI at the edge, we're starting to also be able to create the type of response times that are necessary for the real-time nature and the determinism of these systems. So I think those are some pretty critical properties. I think there's challenges though. When we start to look at AI on edge, there's a lot of problems in terms of, am I going to train it at the edge, and how does that expose me to the resource constraints that exist there? There's clearly a life cycle that's happening relative to AI that's different than the life cycle of edge compute. Edge compute, you want to buy it and it's going to sit there for maybe 3 years, maybe longer. AI is evolving really, really quickly. And so the needs of that AI as it intersects with the compute resources that are present, moving from something as simple as LSTM to maybe we should go to attention-based networks, or I want to start bringing in other capabilities that allow me to do one-shot or few-shot learning at the edge. Those types of systems, I still think they're evolving so fast that they're disconnected from the reality of what I can install today and how long will I depreciate that equipment. So I think we've got some challenges, but I think they're really exciting.
Absolutely. Thank you so much. And again, as you were talking about your stuff on virtual PLC and so on, I just couldn't help but remember when I was at Schneider Electric, we were talking about the whole concept of software-defined automation. And this is essentially the vision that you're talking about when we were used to partner with Wind River and so on, right?
Finally getting there.
Absolutely. So I mean, essentially, software-defined automation was sort of everybody talks about software-defined networking, software-defined storage, but we were thinking about software-defined automation. And again, we were partnered with, so this is great to see you talking about it. I'd like to ask Dinesh, do you want to add some thoughts on edge compute in the industrial IoT space?
No, absolutely. What we see in the industrial space as we talk to the different clients of IBM who try to deploy industrial solutions in manufacturing or in other type of civil engineering or in automotive type of applications, one of the big concerns that is driving edge computing for them is the sensitivity of data. As Vish had mentioned, if you want to make full use of AI, you often end up going to a cloud-based service. And if that cloud-based service is not in your organization, you don't want to see that data go out. So from the manufacturing plant, even if you're doing things like understanding which products are good, which products are not good, or even if you're monitoring, say, the acoustics or visual for any type of activity, our clients want to preserve that data on their premises. So they want edge computing because they would not like to know any of this information about their operation, their statistics going out to the going outside their domain of control. Another approach which we have seen driving the need of edge computing is in the various, I would say, integrated manufacturing fabrications. So IBM runs a variety of labs, and the key part of these labs, as well as key part of many of the industrial settings, is that your equipment from many different vendors. I mean, equipment from Schneider, equipment from ABB, equipment from Mitsubishi, etc. And for some very strange reason, all the equipment providers don't want their data to leak out of the environment into any of the other places. So they are sort of want to arbitrate how the equipment leads, data from the equipment leaves, where it is managed and controlled currently it's being done through non-technical, meaning legal contracts and arrangement. But edge computing provides that approach because a lot of that means the data from these equipments effectively becomes useless for the person who integrates the lab or operates it. So the need to use the data, need for the sensitive data is the one big driver. The other thing that I see coming out in all the engagements around edge and IoT that we're coming in is the question of cost. Like the assumption here being that if you are able to maintain, in the industrial settings, the amount of bandwidth that you pay oftentimes is not fixed. You have to pay certain threshold tier charges to the network carrier provider, especially if you are in a remote area like mining that Malik mentioned. You have to pay per byte satellite charges. You have to pay over certain tiers of cellular coverage, depending on whether you are in a well-connected area or not well-connected area. But if you have to pay these per charge, usage-based charges, either for the network or for the computation that will go out in the cloud computing world, then it often turns out that the edge computing solution is the cheaper and the better approach. So cost and sensitivity are the two factors we are seeing driving industrial IoT applications towards edge computing.
Fantastic. Thank you, Dinesh. So we kind of talked about 5G, we talked about edge compute. Let's talk about the third topic, AI/ML. And as you all know, right, AI has gone through sort of 50 years of R&D, starting from rule-based expert systems to machine learning to deep learning and so on. And in the last several years, NVIDIA has really led the world, right, in using their GPUs to promote the whole world of deep learning and so on. And we are absolutely delighted to hear from one of the absolute leaders there. So, Anima, why did you talk about the opportunity of AI/ML in industrial IoT applications?
Thank you, Preet, and great panel, and great to be here with everyone. Uh, excuse me. So first of all, I think there is huge opportunities for AI/ML in the edge, right? And NVIDIA has been building the EGX platform, from Jetson Nano, more aimed towards hobbyists, to Jetsons and Xavier platform that can now do video perception tasks, whether it is delivery bots or drones with video capabilities, robotics in industry. So there's a whole range of applications that can be brought to the edge. And having 5G capabilities, there is now Aerial that is available on the NVIDIA EGX platform with Cloud RAN. So the ability to do GPU acceleration for also 5G operations nicely integrates with the rest of AI/ML, right? And ultimately, there are opportunities to do better signal processing with AI/ML. So you see a lot more integration of these different processes. And to me, I think the AI/ML also depends on which domain we are talking about, right? So if you're talking about robotics, we have NVIDIA Isaac that is built on top of EGX that can do sim to real in a very seamless way. So we have high fidelity, physically valid simulations. For instance, legged robots, we can now simulate them and have this be trained at scale. So when we have GPU accelerated reinforcement learning methods being applied in simulation, we can do this on millions or even billions of runs. And then we can take that to the real world where the data is very limited. And in many cases, by doing hierarchical reinforcement learning, you also don't need very sophisticated sim to real adaptation. That's because the simulations are, first of all, high quality. And second of all, with the hierarchy, you're ensuring that the low-level controllers are still robust, right? They're traditionally designed controllers. So you're not learning everything from scratch. So I think one aspect to keep in mind is AI is not going to replace the entire pipeline, right? It's going to augment, and we need to design the right methods to augment it well. So there are many other applications of the edge. NVIDIA Clara, now with the pandemic, the healthcare is so important aspect of applications for AI. And we've been enabling federated learning where different hospitals can share their data privately on the Clara platform and be able to train this. But there's also support for the edge. If you now want these models to be served on edge devices like scanners, you can do that, and you can also maintain HIPAA and other privacy constraints. So I think it's not going to be edge specific to one application or domain. There's just such a wide range of them. And sometimes you have to think about more specialized platforms and algorithms to incorporate those constraints.
Thank you so much, Anima. And so, since you mentioned simulation so many times, I cannot help but sort of introduce the fact that when you are dealing with sort of 3G networks, 4G networks, 5G networks, in order to simulate all these MIMO antennas, right, you need to simulate them, and ANSYS again provides through the HFSS tools the ability to simulate all the 5G networks and so on and so forth. And then when you're talking about the edge, you need to sort of simulate those edge devices, the high-tech, the chips and the eMag and the PCBs and so on through our Red Hawk tools and so on. And then you have all these sort of mechanical stuff and the fluid flow that is happening around those antennas and so on. And we sort of simulate them through ANSYS Mechanical and ANSYS Fluent tools. But Amitava in his keynote talked about digital twins. So we are using all of these things to build a digital twin of a manufacturing plant in the presence of all these interactions that are happening. But if you do those at the full 3D level, this thing is going to take forever to simulate. So we use actually AI techniques to accelerate simulation to build or what is called reduced order models. So you can do a very quick, an accurate simulation of your 5G networks with the edge, with sort of accelerated by AIML. So it's kind of an amazing thing how these all fields are coming together.
Indeed, and and in fact, the use of AI/ML to replace traditional solvers in simulations, right?
That is what we are working on. We are actually trying, the solvers, as you know, Anima, they work on sort of finite element methods, finite volume methods, and so on. And we at ANSYS are actually working on using AI methods to accelerate simulation with your colleague, Sanjay Chaudhary, who I'm sure you know, but there's just some amazing work going on in physics in control networks.
Yes,
so, yeah.
And that's what I wanted to mention. The NVIDIA SimNet is able to now accelerate with deep learning, and we also have been doing new research, including one that we've named Fourier neural operator. So marrying the traditional Fourier transform with neural networks, we can now solve Navier-Stokes equations from scratch and do it at high resolution, and that's really exciting for us, that how we can now do all these very expensive simulations and speed them up with AI.
Absolutely. The world around us is governed by the laws of physics, Maxwell's equations in electromagnetics or Navier-Stokes in fluids. And typically those things were solved by finite element methods, and now you can solve it using AI/ML. But anyway, moving on. So now the question that we have is, we have not just these different technologies sort of independently, like 5G and edge and AI/ML, but it's sort of the convergence of those things coming together, right? So I want to ask Dinesh, right? I mean, you are at IBM, you're responsible for the strategy of IBM and your customers, right? So what are some of the challenges and opportunities you see in the convergence of these technologies of 5G, edge, and AI/ML in the industrial IoT area? What are you seeing? Dinesh, you are on mute.
Yeah, thank you. So when we bring all these three technologies together, 5G, edge, AI, and as well as IoT, there are a lot of potential, but there are also several operational challenges in making the system work and operate. And some of these challenges are, I would say, the fact that each of these technologies, and I would count both AI as well as IoT and 5G as being technologies that are new and emerging and evolving. Now, it may sound strange for me to refer to AI, something which is 30-year-old, as new and evolving. I think the applications of AI to serious problems is probably only a couple of years old. And there are a lot of myths and a lot of, let's say, rookie mistakes that have been made about use of the AI. Similarly, 5G is technology that's just coming on board right now. And there are several operational challenges that have been created which will impact it. And I'll share one example of this operational thing. Like, we all know Nokia is a wonderful maker of the 5G systems. And we were trying to use one of their equipment provided by that to set up a 5G system operational in our lab to set up environment and build enterprise grade IoT systems on the edge. And for whatever reason, the operational plan of the design of the device is that it would only work in environments which have at least 20 feet of clearance. Because of the amount of radiation, amount of how close the human beings had to be, it had to be put 20 feet away from where any human activity is. And we searched around our entire building, which is half a mile long. We had 2 spots where we could put that. And they were not the most convenient spots. Now, of course, part of it was that the antenna was designed to perhaps the thought was that the warehouses would be typically 20 feet high. But taking that basic operation, something very simple, that if you have to put something indoor in a traditional lab or a building, you won't have 20 height ceiling, is a mistake which was in the design. And I'm sure there are other versions coming out which will be later on. So I don't mean to downplay it, but this is the kind of evolutionary operational challenge that happens when you bring out new systems. The same happens with AI also, because with AI, essentially, if you look at AI is trying to build a system which is trying to estimate a function through alternate means. And as you had mentioned, we have a lot of physical equations. We can approximate them very well using an AI-based model if you have got data. But oftentimes, when you get the data, The data is not perfect, not aligned, and basically the effort that you save in trying to use AI instead of human modeling to build the function gets decimated by the amount of data that you have. If you build a model in AI, which is highly successful models of AI are deep neural networks, but the deep neural networks themselves, the problem operational that happens is that if I to train an IoT data, I get a gigabyte of training data or a terabyte, depending on if I'm lucky or unlucky. Today, then I get another gigabyte or terabyte a month later, another a month later, which means because of the lack of the ability to combine these AI models, this incremental training becomes a big hassle. Now, there are techniques, there are approaches available, but combining them together brings a problem. So the fact that we are bringing three technologies together and each of them are going through their growing pains creates certain challenges, which I think is the biggest one. The practical solution, when you bring all of these together, you want to have a system which is cheaper for the industrial IoT person to operate, which is easy to maintain, and which operates in the environment that they work on. And getting that maturity at this converse space is what I see is the biggest challenge that we face nowadays.
Fantastic. So Vish, during his sort of introduction on the edge, kind of pointed to some of the convergence challenges. So Vish, would you like to talk about what you see as the challenges and opportunities of the convergence of all three technologies, 5G, edge, and AI?
Yeah, absolutely. I think Dinesh gave a really great overview. My sense is, when we look at historical patterns, when you converge two technologies together, profit pools move. Right? When compute and the network came together, you get the internet. When compute and storage comes together, you get HDFS and data lakes. These things create, new centers of gravity for economies. When I think of 5G, edge, AI, these are all, close cousins when it comes to capability being offered in a disruptive way to a given industry. I can think of AI being applied, to 5G, as a for instance, where potentially you're using it for resource management. There's many different prediction problems that are fraught in 5G. Channel estimation being a big one, especially with some of the new disaggregated architectures where you can get staleness. So the ability to predict and optimize using AI can be particularly useful. However, when you look at wireless technologies, these are architectures that are not optimized for AI in any way, shape, or form. They typically are resource constrained. They have specific missions. They're not general purpose. And for things that would be data optimized, for instance, I'm not getting labeled data out of my wireless infrastructure. And so, we need to do some research in terms of whether unsupervised methods could be applicable. There's a lot of work left to be done to really understand that convergence. Similarly for AI and edge, this notion of intelligent edge, I think is fascinating. Dinesh had spoken earlier about privacy preserving techniques where you can employ federated learning. I still think we're early days in federated learning. I think that there's issues as we aggregate the global parameters in a central core, where that may create synchronization issues. It may create bottlenecks, especially in sensitive networks like radio access networks. There's different ways we can average that out. There's other distillation methods that could be applied at the edge that could give us some advantages. But I really do, I think Dinesh's perspective, see that there's an earliness to the ecosystem. Life cycle wise, we're still not at a point where we can make some stable and deterministic decisions. So I think it'll be fun. This is the point in time when a lot of experimentation happens, and we're going to need to understand how the actors come together to kind of formulate what the new profit centers are going to look like. But I do think it's still early. I think the tried and true model of I'm going to train in the cloud, do some level of inferencing at the edge is going to be the standard in terms of what the application abstraction looks like for some time before we get to some of these more esoteric methods. I do like this notion of edge and 5G. I think when I look at the convergence of those two, that's really, in my mind, where the dividend of 5G is going to come from. If I look at where 5G has, entered into the market to date, it's been on enhanced mobile broadband and 5G standalone. rather non-standalone networks, it's not taking advantage of any of the new service generation that 5G can give. You're not delivering new experiences necessarily to the end user. Most people who wanted to watch 4K video on their phone could have watched it with LTE. I think the true promise of 5G comes from the convergence of wireless and edge. And in fact, I think principally what's going to happen is that the focus for the delivery of value will be the edge and not the smartphone when we think about 5G. I think that that's going to be something to watch. So when I think of the convergence of all these technologies, I can see some parts that are mature and are going to catalyze, some parts that are still some way out, but are going to create disruptive entry as soon as we start to align those forces. When we figure out how to really leverage AI for 5G and build it in as part of the radio access network, things like radio resource management, even doing learning-based OFDMA could be surprisingly disruptive in terms of how we can reuse time frequency resources. There's a lot of different things on the interference cancellation side of things, especially with SIC, that we can benefit from AI. So I think that that's a meaty area. It's probably more 6G in many ways in terms of where it's going to come. And then AI and edge. I think it's closer. I think we're getting there. I think the research from folks like Anima and others are gonna deliver on that dividend. It's going to come within the next 5 years before we see, I think, real production grade capability in that realm. But we're getting closer. So I think the roadmap looks very, very optimistic.
Fantastic. And actually that really, you talked about, well, people are doing some experimentation, some early deployments and so on. So I want to go to Malik and see that at Ericsson, I'm sure you're seeing lots of deployments of these IoT applications, early deployments and so on. And again, at ANSYS, I see lots of, let's do a POC on this, a POV on that and so on. So what do you think are sort of some of the early IoT deployments, right, in early deployment phase? And when do you think these technologies will scale, right, across to really take advantage of the benefits of 5G? So early deployment applications and sort of a prediction of the future, please, Malik.
Absolutely. In fact, just follow on what we said before I answer question. Just want to, from our point of view, there are 12 constructs that are going to really make a difference. In the networking world, we talked about abstracting the hardware from underlying software. We talked about programmability. We talked about virtualization and orchestration. That's in the networking world, right? In the compute world, we talked about cloud native, which is containers, microservices, CI/CD pipeline, DevOps. In the AI machine learning world, our friends talk about data based on the data sets, is it supervised learning, unsupervised learning, reinforced learning, or even explainable systems. How these constructs are going to come together and realize that distributed, disaggregated, and a densified network is going to define that scalable implementation that you're talking about from technology perspective. Yeah. But as a initial thing, we already started certain things. Even within our own Ericsson, we started Smart Factory in Texas, with a dedicated 5G network on site, with Edge and AI integration on the 5G dedicated network. So we are starting to see early implementations and deployments of this. But if I had to really bet the mass, I would say these 12 constructs I mentioned about between networking, compute, and AI machine learning have to come together to realize the distributed, disaggregated, densified, and also diverse. It's a diverse environment, In the case of 5G, 3GPP standards, in the case of cloud, CLCF, in the case of AI, ML, some other standard bodies. So there is a diversity of standard bodies, diversity of vendors, all have to come together to realize that mass scale deployments.
Absolutely, Malik. But can you kind of address the question about the early deployment, the stage of deployment, and where you think this will scale?
Yes, so the scale of deployment is still early. If the only way to scale is to get these constructs and the players together to realize the value chain that Vish talked about, and it may take at least next 3 to 5 years. Right now, we are
So
still.
that will be, so basically my question is, are we going to start doing early deployments of 5G and it'll take 3 to 5 years for it to happen? And meanwhile, Amitabh talked about 6G, right? So essentially, are we going to first have full scalability of 5G applications before we wait for 6G, or are you seeing early deployments of 5G already?
Early deployments of 5G today is called non-standalone. So that's combined with, basically leveraging existing 4G LTE infrastructure. So the standalone will start sometime in 2021, the commercial deployments. So that's when you see end-to-end network slicing. And that becomes a foundation for industrial IoT use cases. So the early use cases are just starting, but main majority is going to be seen in 2023.
Fantastic. Vish, do you have any thoughts to share about the stage of deployment of IoT applications in the convergence of 5G and Edge and AIML? What are you seeing?
Hey, Paul, before we get to Vish, we have about 3 minutes left in this.
Okay. Then let's actually, I was not quite sure about the timing.
Right.
In that case, let's just move on to other questions. Actually, there's a question I absolutely wanted to address the panelists, right? Given that we are at the CWC at UC San Diego, right? It's about the role of there's a tremendous amount of research and development that is happening, right? In academia, some in industry, and again, so I would like to ask Anima, because she sort of sits 50-50, right? 50% professor of Caltech, 50% at NVIDIA. I don't know how she does two sort of full-time jobs in 50%. But what is the role of academia and industry, right? Collaboration while researching these issues, and where, if you can point to some universities that are doing some outstanding work in this area, other than Caltech, and best ways for these people to work together. I mean, that would be the right thing at CWC.
Yeah, indeed. And, we now have great opportunities to bridge the gap, right? So I don't view it as 50% one versus the other, but integrated approach to research, having the freedom to think about next generation methods, right? Like I get the foundations at Caltech, there are amazing students and researchers, also expertise from scientific domains, when we are thinking of how to solve problems in seismology, how to understand earthquakes, or quantum chemistry, how to speed up Navier-Stokes equations. So there's a lot of that domain expertise that's so critical, right? We cannot go as AI ML people and say, okay, let me just put a neural network here. There needs to be this integration that's coming about. And also in the wireless networks realm, like Baba Kasibi, Michel Efros at Caltech, right? So much of also the foundations from information theory, signal processing, how to bring that with AI is, I think, where the next generation research will happen. And on the industry side, having the scale and engineering, like the platforms that NVIDIA is building, whether it's the Edge platform, NVIDIA Isaac, right, Clara for healthcare, all these are so critical to enable the best hardware capabilities, because, you need good abstractions on top of it to quickly prototype new algorithms. So I see this bridge coming together as the way forward. And there are so many universities now that are much more open to these kind of collaborations. We see that with Berkeley, the Bear, RISE, so many different centers there that are closely working with NVIDIA and other companies. So I see more of this model happening, and universities hopefully are moving to this new realm and allowing for this flexibility.
Absolutely. And in fact, Professor Henry Chisborough at Berkeley has talked about the role of open innovation, right? How essentially companies can, instead of doing research in a closed way, they can partner with startup companies. And again, at Ansys, we are partnering with both universities and startups in this area. But I'd like to have, I know Malik is big on this ecosystem, right, play. So Malik, can you share some of your thoughts on industry-academia collaboration while we wrap up the panel?
Yeah, absolutely. In fact, at Ericsson, we have a huge research team, about 900 researchers. We do have such a collaboration for last several decades with universities. So as an example, we did a King's College collaboration where we demonstrated the first 5G system working with Vodafone and King's College. So the thing that worked out extremely well is that not only just doing the research, but translating that into standards, as well as into proof of concepts and the productization. I think that particular connection makes a huge difference in taking the innovation into commercialization.
Absolutely. And again, I need to acknowledge UC San Diego. I mean, look at Sujit, what a platform he has put together, right, for industry, whatever collaboration. I have rarely seen in a university so successful in bringing the absolute top leaders from industry and into such a setting. And again, I know your Chancellor Pradeep Khosla personally. He's from IIT Kharagpur, so he and I talk all the time about the role that what he's trying to do at UC San Diego. So absolutely, you are blazing the way at UC San Diego in this industry academic collaboration. With that, I would like to summarize. We are at the top of the hour. Thank you very much
Like
to
to
all the panelists and appreciate all the support. And it has been a wonderful panel. Again, I was going to summarize the discussions, but the quick summary is these are the three technologies: 5G, Edge, AI/ML are absolutely converging. Super exciting applications as you heard about, but we are just beginning the journey. Just stay focused. There's so much work to be done in the future. Thank you so much, Sujit, for inviting me.
Thank you.
Thank you. Take care.
Thanks, Chris.
Great. Thanks for the excellent panel and all of you, the panelists.